Hello everyone, and then welcome to another video. Okay, so in this video we'll be treating multiplication of matrices. Okay, so in case you are new to this channel, kindly subscribe. Okay, hit on the bell icon so that you don't miss out on any uploaded video, and then like the video so that it gets pushed to other students who might need this video to enhance their studies. Okay, and then I'll answer all your questions in the comment section. Okay, so let's dive right into this video. So first, you need to know what the rows and column of the matrix. Okay, so let's say you've been given example. Okay, so let's say you have matrix A, okay, to be 3 1 4, okay, and then maybe matrix B, okay, to be 4 maybe 2 6, okay, and then you have 3 5 8, okay. Right, so first let's look at what the rows and columns. So from here you could notice that in case you've watched my previous video on addition and subtraction of matrices, you will notice how to find what rows and columns. Okay, so rows are the horizontals, okay, and then columns are the vertical. Okay, right, so from here you can notice that we have 1 by what 3 what matrix order, okay, and then there's what 1 2 3 and then 1 2, so we have what 3 by what 2 what matrix order. Okay, so now let's proceed. Again, this is one of the most important things you need to know. Okay, first, okay, so we know that these are row 1 and then what column 3, okay, and then we have row 1 column what 2, right? First, the first thing first you need to know, okay, first things first, the first column, okay, of the matrix has to be always equal to first row of the second matrix. Okay, so the first column of the first matrix has to be always equal to the first row of the second matrix in order for two matrices. Okay, so in order to multiply two matrices, okay, so we can notice that this is equal to this. Okay, so we know that 3, this is 3 and this is also 3. Okay, it means that we can multiply the two matrices. Okay, so in short, the column of the first matrix has to be always equal to the row of the second matrix. Okay, so from here we have column 3 and here we have column 3. Okay, sorry, row 3. Okay, it means that we can multiply vector A and B again. Always their order has to be the same. Their order has to come from the remaining rows and column. Okay, so first we know that this row 1 for the first vector, so 1, okay, and then there's the column for the second vector. Okay, it means that the answer we'll get from multiplying vector A and B would be a 1 by 2 matrix. Okay, so first, whenever you want to know that two matrices can be multiplied, first column of the first vector has to be always equal the row of the second matrix. Okay, again, this is very important. That's why I'm really emphasizing. Okay, listen to this attentively. Okay, in order to know that two matrices could be multiplied, okay, always check that the column of the first matrix has to be equal to the row of the second matrix. Okay, so from here we know that there's 3 and there's 3, so they are the same. And then once you find this out, you automatically know that the order of the matrix will be the remaining of the rows and column of the two matrices. Okay, so this row 1 and this column 2, so the final order of the matrix will be 1 by 2, okay? So one row 1 and 2 columns, okay? So let's do the multiplication. Okay, so we have what? A multiplying what? B, okay? So we have what? 3, 1, 4, okay? And then multiplying what? 4, 2, 6, and then we have 3, 5, 8, okay? So let's do the simple what? Multiplication, right? Okay, so this is what? We multiply this by, multiply 3 by 4, multiply 1 by 2, and then you multiply 4 by 6, okay? So you do the same thing for the second what? Column, okay? So you multiply 3 by what? 3, 1 by 5, and then 4 by 8. So first, let's multiply the whole of this by the whole of this row by the whole of this column, okay? That's the first thing we are doing, okay? So we have what? 3 by 4, that's what? 12, okay? 1 by what? 1 by 2, okay? So when you multiply 1 by 2, you get what? 2, okay? And then when you multiply 4 by 6, okay? When you multiply 4 by 6, you end up with what? 24, okay? Right, and then let's move on to the second part, okay? Right, so we have, so we can just compute this, but let's move on, okay? So we have the second part. So now we are multiplying this entire row, okay, with this what? Column, okay? Right, so let's proceed, okay? So we have what? 3 multiplying 3, that's 9, okay? Plus 1 multiplying 5, okay? That's 5, okay? And then you add that to what? 4 multiplying 8, that's what? 32, okay? Right. So let's simplify this, okay? So once you simplify this, when you add this together, you have 12 by plus 2, that's 14, 14 plus 24, okay? 8, okay? And then you have 9 plus 5, that's 14, 14 plus 32, okay? That's 40 what? 6, okay? Right. So this is the final answer, okay, to this question. So you can further use your calculator to find check for the final answer, okay? So in order to verify whether two what matrices could be what added or subtracted, let's do the reverse of what A multiplying B, okay? So now let's see. Let's say we have what? Now B multiplying what? A, okay? So let's try find that out. So for B multiplying A, we have B multiplying A, B, okay? So B we have what? 4, 2, 6, and then we have 3, 5, 8, okay? And then we have what? A. So A is what? 3, 1, 4, okay? Now, let's check whether we can multiply these two matrices, okay? So this is what? 1, 2, 3. We have 3 rows, okay? So 3, and then multiply by what? 2 columns, okay? And for this, you only have 1 row multiplying what? 3 columns, okay? So in order to check whether two matrices could be multiplied, check the column of the first matrix, and then you compare that to the what? Compare that to the row of the second matrix to find out whether they are the same or not. In case they are the same, it means that you can multiply them. But in case they are not the same, it means you cannot multiply them. So from here, you can notice that the column for the first matrix is 2, but the row for the second what matrix is what? 1. It means that they cannot be multiplied because they don't have the same what corresponding rows and columns, okay? So now let's proceed to the second example, okay? Let's say we have a vector A to be 1. So let's first check for the what? The rows and columns for matrix A, okay? So from here we have 2 rows, okay? And then we have what? 3 columns, okay? And then let's look at what B. So for B we have what? 3 column rows and then what? 2 columns, okay? So in order to check whether you can multiply two matrices, you have to check for the what? The column of the first matrix, and then you compare that to the what? The row of the second matrix, okay? Again, you check for the column of the first matrix, compare that to the row of the second matrix. In case they are the same, it means that what? You can multiply, okay? You can go ahead and multiply. So let's check. Right, so from here, you can notice that the column of the what? The first matrix is what? 3, and then the row of the second what? Matrix is 3. It means that we can go ahead and what? Multiply, right? So now, in order to find out the order for the what? Final answer you will get for the multiplication of these two matrices, which have the same column and row, okay? You will just check for the what? These rows and columns, okay? So you check for the row of the first matrix and then the column of the second matrix. So you can notice that you end up with what? A 2 by what? 2 matrix, okay? So let's do the simple what? Multiplication. So we have certain A multiplying what? Vector B, matrix P, okay? So we have what? 2 multiplying 0, that's what? 0, okay? Plus 1 multiplying what? 1, that's what? 1, and then 3 multiplying 2, that's what? 6, okay? So let's proceed. So we have another what? 2. So we are multiplying what? 2, 1, and 3 by this row by this what? Column, okay? And after that we will multiply the same row by the second column, just as we did for the previous example, okay? So now we are doing for the second column. So we have 2 multiplying 1, that will give us what? 2, okay? Plus 1 multiplying 2, that will give us what? 2, and then 3 multiplying 3, that will give us what? 9, okay? Now let's move on to the second row. So we have 4 multiplying 0, that's what? 0, plus 1 multiplying 1, okay? That's 1, and then we have minus 2 multiplying what? Positive 2, that's what? Negative 4, right? So now let's move on to the second column for the B. So now we have 4 multiplying 1, that's 4, okay? Plus 1 multiplying 2, that's 2, and then we have minus 2 multiplying positive 3, that's what? Negative 6, okay? So you can punch this on your calculator and then you arrive at what? Your final answers, okay? So we have what? This will give us what? 7, okay? And then we have 9, this is 11. 9 plus 2, that's 11. 11 plus 2, okay? 13, okay? And then we have this 1 minus 4, that's what? Negative 3, okay? And then we have what? This 4 plus 2, okay? That's 6. 6 minus 6, that's 0, okay? Right, so this will be the final answer for this question, okay? Right, so you can do for the reverse to check whether you can multiply B times A, okay? So let's check whether you can multiply B times A, okay? B times A. So for B times A, we have what? We have a 3 by 2 matrix, and then a 2 by 3 matrix. So from here you can notice that we can, yes, it's true, we can multiply B by A, okay? So because the column for the first matrix is equal to what? The row for the second matrix, and then you will end up with what? A 3 by 3 matrix, okay? Right, so you can go ahead and then, okay, solve for that. You arrive at a specific answer, okay? So in all this, I will introduce simpler trick you can use to solve matrices in less than 60 seconds, okay? It could be even less than 30 seconds, okay? It's just a simple approach, okay? But this is what an introduction that will broaden your understanding, okay? So kindly subscribe and then hit on the bell icon so that you don't miss out on any future videos, okay? To help augment your studies, like the video. Let me know your questions in the comment section, and I will see you in the next video. Bye bye.